Awesome. Cool. Yeah, thanks again, everybody, for joining. Good to see y'all. Looks like things have been rolling along pretty good here the last week or two. Good start to 2022. I don't know how many of you guys saw my announcement in the when I posted this event a few days ago. We have a handful of engineers from the Solana Labs team on the call today. Also, Tao Zhu is here with us. He's one of the developers on Solana Labs. And I asked him to speak on kind of some of the improvements that have been coming in 1.8, as well as some things that are currently being worked on to look forward to in 1.9 regarding the compute unit, cost modeling, quality of service, and block packing optimizations, all of which we hope shall continue to make the network run more smoothly as we implement these things over time. So I'm going to kind of keep, hopefully, myself down on mute for most of this, and I'm going to hand it over to Tao and kind of let him give an overview, and we should have plenty of time for questions and any discussion thereafter. So take it away.
All right, thanks, Dan. Hey, everybody. This is Tao, like Dan said, dev from Solana Labs. I'm based out of Chicago. So I'd like to use the opportunity today to talk about what the cost model in 1.8, which is mainnet, or 1.9 in testnet that does and does not, why it values, and maybe touch base some of the details about how it does its job. If you have any questions or comments, please feel free to interrupt, because discussion is always better than just talk. So let's get to the first thing out of the bat. What the cost model does not do is it's not fee governor. It does not set fees for transactions. What it does do is to optimize. It's a tool for the leader for the banking stage to optimize the block production. So the goal is for a leader to produce a block that can be reasonably, on average, by any validators on the cluster within a slot time, which is 400 milliseconds. Meanwhile, to maximize blocks parallelism. And why it's important. So early, especially during the bots attack, leaders could possibly pack in too many transactions into a block, and the cost of block in some cases takes seconds for validator to replay, and the validator will missing its leader slots and causing the forking, routes not routing, and all that. It's a risk. And with this feature, what the cost model right now in mainnet and the testnet aiming to do, the goal is to make sure the block the size is reasonable enough that all the validators can replay with the slotlet, so nothing will fall behind, and also trying to maximize its parallelism. And to that end, there's two limits being set for the block. One is a block limit, overall limit. That is essentially to make sure the block's not too big, not too expensive. The second one is a single writable account maximum limit. We don't want to block all the transactions in the block writes the single account, and then we cannot really spread them out on the concurrent processes. So what is the limit? The limit is compute unit. Compute unit is a constant. It's a deterministic cost determined by executors to say, hey, this program is going to cost this much. Each actions we do will cost this much. Compute units, load the VM, compile it, execute it, calling the sysvar, writing to account, and so on. All those actions, activities per se, has associated compute units that is constant across the cluster. Using the compute units mapping to the replay time requires a conversion that is from compute unit to the microseconds. This conversion is obviously hardware dependent. Faster machines can execute the same amount of compute units in faster time. Slow ones, machines takes a longer time. So there's a conversion. Like I said, the goal was to get the average validators on the cluster to be replay the block within the time. So the conversion, the ratio is also taken as an average of the cluster. So some of the validators may be too slow, will not be able to catch up, to take a longer time, and it will miss its own leader slots. Few of the validators missing leader slots won't cause any problem to the cluster, because that's what the cluster built for. And that actually serves a motivation for those validators to upgrade their hardware. The other thing about the cost is programs cost are predetermined, but instructions cost varies. Instructions cost depends on how many sub-instruction it has, depends on the accounts it's going to touch and how big the accounts are, so on. So instructions costs are estimated. Whenever a instruction being executed, its actual cost being reported and put into algorithm to get the overall estimated cost for the instruction. So next time the instruction comes in, the cost model will use the estimation to say, hey, this instruction likely to cost this number of compute units, and we're going to budget that in that way. And this algorithm is pretty simple. It's just mean on the weighted moving average plus 3 delta deviations, because we want to get the cost slightly on the high end to be safe. Any questions so far?
So is this conversion ratio between like compute units and like actual
microseconds?
Like, yes, is that like dynamically like determined?
No, so we build a dashboard. So essentially, this is a good question though. So the reports of actual costs versus microseconds are reported by replay stage. So all the validators, when they execute a transaction, they reports how many microseconds they spend on the instructions that being calculated have how many compute units. So it reports these numbers to the matrix. And on the matrix, we run the aggregate queries to say, hey, cross the clusters for this particular program ID. What is its CU? What is microseconds? And divide by that, we get this ratio average.
But the point is, like, the actual like developers have to look at these metrics and like basically tune these like constants.
No. So the constants is statically defined in the code.
Yeah. So basically, like, we have to like look at the metrics and like figure out these constants.
Yes.
Okay.
And this constant should not be changed so frequently. Normally, in fact, and ideally, we haven't had a chance to change it yet, or we did it once, but during the test. But ideally, this number changes because this is the only thing that connects the constant world where the CUs are to the real world where the microseconds are.
Yeah.
So anytime we change this number, we should be feature guarded.
Yeah. And
yeah, again, this number is a dashboard. You can run the queries on the matrix to get the different networks, CUs, and the numbers should change constantly because it depends on the hardware's joining the clusters, they're being upgraded or not, behaviors of the programs, things get more complicated, it takes a longer time to execute. So yeah, a lot of variations over there. So we smash them together and get a single one number. Want to be on the safer side. That's why we put 3 standard deviations on top of the mean. And the goal for the number doesn't need to be accurate. It just needs to be static. So the goal will be the blocks produced will be replaced by most validators on the cluster within the slot time.
And the idea is basically just that like hardware will like tend to only get faster and stuff.
Yes, that's why you cannot use microseconds as a mean to calculate the block cost or expense, right? Because microseconds change everywhere. Cool. That's a good question. Any other questions? So just want to point out. Go ahead. Sorry.
Sorry, I was just going to make a clarifying remark because I know you mentioned this at the beginning of the talk, and I just kind of wanted to make sure that the point got all the way around. The goal of all of this is to make it. I think you maybe mentioned this. Is to make the replay stage for the vast majority, right, 3 standard deviations of all the validators, no longer than a single slot time, right? Because the thing one of the factors that we believe was driving a lot of forking was excessive replay times, because the total compute packed into a single block exceeded what any replaying validator or what any validator could replay in the time given to it in the following slot.
Yep, well said, Dan.
So do you see a lot of variation between I guess you're collecting these numbers. Is there a wide variation between capabilities of validators that you see, or are they all packed within a pretty close range of capability?
Oh, good question. So the hardware's, the validators' performance are vastly different. So the bandwidth between the high performing and some slow ones is large. So some slow machines, again, will miss, even with this, they will miss their leader slots because of long replay time. And again, like I said, this would serve a motivations for them to upgrade their hardwares, for them not to miss the leader slot.
And is this information about how a particular validator is performing something that is easily available to validators? I imagine that maybe if we looked at our logs or something, we would see it, or if we knew how to look at the metrics site. But since you already probably do a lot of that, is it worthwhile to make this information more available and accessible to validators so they can sort of self-select better hardware?
Yeah, well, so to the end, it's like, well, first of all, if you keep missing a leader slots, something's wrong, and you're gonna do something about it. If you dig into it, probably will be seeing it. We don't have like sort of notifications or warning to say, hey, you've been too slow, because slow is a relative concept, depends on how the other validator is working. I think missing slot is a first warning sign, this flag to look at for. And if you look at the matrix on the replay stage table, I believe, and you will see on your particular host how long it takes how many microseconds it takes to run those transactions, and as well as the compute units. And if you do a division between the compute units to the microseconds, and if you get the ratio much lower than the published ratio, then that's probably a good indication that the system running slow.
Yeah, I mean, that's great and useful information, but I bet that there's a lot of validators that probably just want to go right to whatever number you just said without having to look at charts and, and do their own math. Not that, only because anything we can do to sort of first of all, let validators understand how their performance ranks. It doesn't have to be in absolute terms, but just, are you 80% as good as, the average? Are you 110% as good? And then have that be easily available might encourage validators and make them even aware that they might have something to do. So.
That's good suggestions. I'll just write this down and I'll look into it with the team to see if there's we can provide easier ways to notify the validator, say, hey, you may be running slow.
And actually, just out of this is like more of a curiosity question, but like you mentioned like 3 standard deviations and stuff, right? Like I'm actually kind of curious. Does it actually like make sense to assume like the performance of the validators like follows like a normal like distribution, or is it like, for example, like some validators just like super fast and it's just like, I don't know.
No, yeah, I guess it's a good question. You don't really necessarily know how the performance of each validator distributes, how they lay over there. 3 deviations, the way of this mean on plus 3 deviation on weighted moving average allows us to move this whole formula up and down together with this moving average. So it's just a way of coming up with call it simple data, right? Massage them together into single measurement that we can tune it for the system, versus multiple knobs everywhere trying to achieve more accurate, which I don't know. It's a cost and benefit discussion, I guess.
Yeah.
Then the cost, right, will be even much higher.
So like Dan mentioned, this whole cost model thing here is for the the main goal is for the quality of construction of the block, and it falls into the umbrella of quality of service for the leader. There are a few more things down the road to improve that. It's just refining the how leader works. And one of the thing is there's a PRs open on the GitHub about when we essentially we want to have a validators have n number of percentage of stake, have this n percentage rights to say what put into the block. So when the leader putting the transactions into the block, it will do a random shuffling, but based on the stake weight. So the transaction coming from the validator have a higher stake, has higher probability to be put into the block. And that should help us to deter and excluding more bots transactions in the event of attack. And there are also PRs open there, have a discussion and code going now to deter the bots attack by charging more fees if they allocated account without actually writing to it. And there's of course still bankless leader down the road, which is not a pressing issue right now, because right now the slowness usually caused by the replay, validator replay, not the leader producing the block. But just want to put this out so you guys know what to look in for, and to put comments on the GitHub, on the PRs.
Can I ask you to clarify?
Yes, sir.
So you said stake weighted, by stake weight, validator forwarded transactions will be included more readily in blocks. Is that what I'm understanding? So, but for a transaction to meet that criteria, it has to first be forwarded. So that only affects transactions that first hit a validator, and then that validator forwarded them. Is that most transactions, or is that only transactions?
I think that's the most transactions. Yes. I'm sorry.
Well, I know that RPC nodes also submit transactions, so those would then be lower priority. They'd first have to hit a validator from an RPC node and then get forwarded before they get higher priority. Is that what you're saying?
All right. Okay, I cannot clarify this right now. I think RPC go through, you know what, I will have to double check this and get back to you.
Okay, that's fine. Thank you.
Randy, you want to go first? Oh, you're going to pull out your notes. Yeah, go ahead.
Yeah, I'll get back to you on the Disco validator discussion over there. Any other questions? All right.
Tao, there was a quick question in the chat from Smith about any time that the hard-coded constant might be changed in the future. I believe you mentioned, I just want to confirm, earlier on in your chat that a future change to that value would be feature gated.
Yes.
Is that correct?
Yes, that's the plan.
Okay.
So once we found the validators, the class doesn't move far away from what we know, last snapshot status, and we want to change the number, we will make a new release, and that should be feature gated.
Great. Okay. Yeah. So TLDR there, these wouldn't change willy nilly between.
Right, and we don't expect this to change so frequently. It should be rather more static than continue changing number.
Mm-hmm. Awesome, Tao. Thank you very much.
All right, thank you, guys.
Looks like we might have another question here.
What happens to the transactions that you drop because they don't no longer fit in the block?
What if transaction being dropped and what was the second part? I'm sorry.
So what happens to those transactions that you drop?
Well, transaction being dropped. So even without a cost model, transaction will still be dropped. So when the transaction can fit into a block, so gated by a cost model, it will be put back into the retry buffer, just as it is right now. And it will be either retrying the next block or be forwarded to the next leader. And it will sit there until it expires.
I see, thanks.
Mm-hmm.
I'm sorry, I don't want to perseverate on this topic, but it is interesting to me to think about prioritizing forwarded transactions by stake weight, because it means that a leader with high stake will have its anything it couldn't handle forwarded, and then the next leader will prioritize those. But if it can't handle them, then they get forwarded again, and the leader after that will not prioritize them. I'm not really understanding what that achieves, because it almost feels like it's just happenstance of what leader happens to be running when a transaction couldn't fit in a block.
Right. Yeah, that's good topic. Let me put the PR in the chat so we can. It might be better just to bring the discussion to the particular PR we're working on. Oh, sorry. Let me find it real quick. So posted the PR on the chat. So this PR links to the next one. Two PRs work together for the functionality. We're still testing it. But what you said is a good input that we should put into the test consideration. Yep, that's why it's still in the pipeline.
Awesome. Thank you. Thanks a lot, Tao.
All right.
So yeah, we're just about at time. Appreciate the input from the tech team. So it's not just always me blabbing at our community of wonderful validators here. So yeah, is there any other final questions for Tao or more generally before we break today?
Sorry, I'm gonna ask another one. I know that compute units. I think people often confuse transaction packing and compute unit computations with transaction fees as a mechanism for trying to discourage, too many transactions being submitted. Are transaction fee, which one is likely to, what is the sequencing of these? Are we going to see compute unit changes before transaction fee changes at the same time? Are these, when can we expect kind of both types of changes? Because the transaction fee changes could have much more wide-reaching effects on all kinds of economics. And I'm curious to know what the track is for those changes also.
Yeah, I can take that one. So the compute unit changes, I think, are very likely going to be coming in soon, most likely, I believe, in the 1.9 branch. Any changes to transaction fees is something that, like, you're effectively tinkering with the core economics of the blockchain and kind of the driving factors for validators and clients. So that's actually a much larger and I would say kind of a more sensitive consideration. It's not off the table. I'm just saying like this isn't going to be just patches pushed in code. This is going to be like something that we'd want to make sure we have like a community governance vote or proposal before we would make any sort of economic changes. Some of the lessons learned from the compute unit, feature additions can be used to inform potentially updated economic models and effectively creating like a fee market. But I think it's a little too early to say exactly how those two things would interact with any kind of specifics right now until more of the cost model features are implemented on mainnet.
So the transaction features are not in 1.9. I guess there was a time when I thought that something was happening in 1.9, but we shouldn't expect anything like that in 1.9 is what you're saying.
Yeah, I believe that's correct. I think there was some confusion around the terminology of cost model. The word cost, right? Might think certain things, but it's always been compute cost rather than actual fee cost. This, again, like I said, this could be used to inform a fee market change going forward. And so it is definitely, I think, attached to some forward-looking, thoughts and ideas. But it is going to be a separate implementation before we see any changes to the current fee structure.
So a follow-up, the congestion modeling for changing fees, is that going to change? Because that seems like it should perhaps be tied to compute unit instead of signature accounts, which ended up kind of being inadequate for that purpose and not allowing any congestion model to even sort of take effect. And at least as I understand it.
Yeah, I don't disagree, but I'm hesitant right now to make any promise on that, again because of this sort of I want to see like the full compute unit model roll out before we would update like congestion based fee economics. I mean, it's a fair point, right? I think this is definitely something that we need and we want to see put together. I just want to make sure we are judicious and careful with what else we might inadvertently introduce, if we jump into something like this too quickly.
I think that that is the direction that we're heading, is to move congestion away from just SIGs and fees in general away from just SIGs and base that more on a more overall approach to what load transactions put on the network, which includes both signature checking as well as compute units.
Awesome. Thank you, Jack, for the added color. Jack is also one of the most senior engineers at Solana Labs, for those of you guys who may or may not have seen him around. Well, great. Thanks everybody for your time. We're a few minutes over, so I'm going to call it here. Thank you, Tao. Thank you, Zentetsu, and everyone else who had questions and feedback for us. Yeah, just really appreciate the engagement. So as always, we'll see you guys in a couple weeks. Thank you very much. Bye.
Thanks, man.